Ready? Set. Here we go. So page 121, 122, right? So write the equation of the line passing through the two given points. Leave the answer in point-slope form. That's what we've been doing, right? Yeah. Is there any questions on problems 1, 2, or 3?
Wait, what am I doing?
3. All right. Problem number 3. First thing I'm going to do is just label x1, y1, x2, y2. Once you've labeled the problem with x1, y1, and x2, y2, keep the x1 throughout. It'll just be easier. So find your slope. So it gives us a slope of plus, that's what, -2 over -4, which is positive half. Is that right? And then leave it as point-slope form. This is point-slope, right? So y plus 2 equals 1/2 x minus 8. If you labeled it backwards, then you could have gotten this for an answer as well. So both answers are correct. You pick which one you had labeled. Any questions more on 1, 2, or 3? And then let's see, 4, 5, 6, 7 says write the equation of the line passing through the given points. Use point slope to set up the equation and convert it to slope-intercept form, meaning we will then solve it. Is there any questions on 4 through 7?
5.
5. Any others? 7. Okay. So number 5, we have 10 comma -9 and -5 comma 3. Let's label this x1, y1, x2, y2. So find the slope first. Stop with the pen, please. What is that? 12, because it's plus over -15. And I can reduce that fraction, put the negative on top. Let's see. 4 over 5. Is that right?
Wait, it doesn't work out when you try to go into slope-intercept. Or just.
Oh, it doesn't?
Yeah, it doesn't work out.
Okay, well, let's do point slope, which is this. It does not work out because you start dealing with fractions. Is that what you're saying? Okay. Well, that happens. 5 plus 9 equals -4 over 5. X minus 10, is that right?
Yeah.
All right, so they want us to go slope-intercept, so I'm going to distribute here and here. So I get y plus 9 equals -4 over 5x. Negative times negative is positive. 4 times 10 is 40. 40 over 5 is 8.
Oh.
And then subtract the 9.
Wait, so just multiply the top by
Yeah.
10 and then divide by 5.
Yeah, it's just all you're doing. Top to top, bottom to bottom. And then 7 was the other one. Does that one look okay? So here's our answer down below here. All right, number 7, we have 4 comma half and -3 comma -3. So x1, y1, x2, y2. Slope equation is this. So -3 minus half over -3 minus 4. So that's -3.5, right? -7. Which comes out to positive 1/2. Good. That worked nicely. I like that. 7 point slope. So I'm going to get y minus half equals half distribute 1/2 x plus 2. Oh shoot, minus 2. That's a minus. And then add half. I add half. Minus 2 plus half is negative 1.5. Or negative 1 1/2. Cool. 8, 9, 10? Any of those? 8, 9, 10? Whose paper is this one? Is that somebody's? Somebody hand me a paper. No? Yeah, it looked like the other day. Friday? Someone hand in Fridays? There's no name on it if you did. Well, I'm sorry, 8, 9, 10, was there any questions there?
8 over 8.
8? Equation goes through 7, 1, has a slope of 2, 5. Okay. So we're going to use point slope to set it up. So I have x1, y1. Y plus 1 equals 2 over 5, x minus 7. And I think they want us to do it into slope-intercept form. So let's distribute over the parentheses. Ooh. And then we'll subtract 1. Minus 1. Minus 1, this can be the same thing as 5 over 5. Minus 19 over 5. Done.
That's 2 times 7. Wait, well, how'd you get 19 on 5? That's the thing I don't get.
I can't clarify it up there anymore. 1 is the same thing as 5 over 5. Common denominator.
Oh.
Anything else on that front page?
10.
10. Find the equation of the line that is perpendicular to the line of number 8. So perpendicular to number 8. So I have a slope of 2/5 of number 8. Number 8 has a slope of 2/5. What do you want to have?
Negative 5 over 2.
So the perpendicular slope is this. You need it right here. Find the equation of the line that's perpendicular to number 8. So we found the perpendicular and goes to the point 44. Is that enough? Yeah. And we want to go through this point. So point slope equation is this. That's x1 and y1. We're going to use the perpendicular slope. Distribute over because we want to convert. Plus 20 over 2. 20 over 2 is 10. Add 4. Done. Now let's do 11 and 12 both. Sound good? Number 11, write the equation in point slope form containing the point 3, 8. So this is number 11, right? 3, 8, and negative 2, negative 27. And so we have x1, y1, x2, y2. Slope equation is this. Negative 35 over negative 5. Negative over negative is positive, so I get a slope of 7. It's 35 over 5, 7. Okay, so then use point slope. Okay, so that's good. Use your equation to determine the value of x when y equals 1. Okay. So when y is 1, that means I'm going to plug a 1 in right there. So I'm going to get 1 minus 8 equals 7x minus 21 if I distribute. So that's negative 7 equals 7x minus 21. That's a 7. Add 21. So that becomes 14. So x has to be equal to 2. Find the value of y when x is equal to 5. So on that one, I'm going to plug 5 in right there. So I get y minus 8 equals 7 times 5 minus 3. Y minus 8. That's 2. That's 14. Add 8. There you go. Cool. Now we got a little story problem that we get to build upon, right? Harold. Well, that's a name you don't hear. It's like 1950s name. Harold rides his bike to school. 10 minutes after he left, he was 11 miles from school. 20 minutes after he left, he was 9 miles from school. So he's getting a little closer. Okay. So let's figure out our points. 10 minutes after he left, he was 11 miles from school. And then 20 minutes after he left, he was 9 miles. Okay, so I was just putting those in context, so I could just do this.
Wait, how do you know minutes is the x and miles?
I was just guessing.
Just random?
Yeah, I was just reading in the order we're in, going, okay, let's go with that. It might not make sense, but if it doesn't make sense, then we can flip it over. Because we're used to miles per hour, right? Or feet per second or something like that. So it might or might not. I don't know. Let's find the linear equation. I should read the rest of the problem. Write the linear equation in function form that models Harold's distance from the school as a function of time since he left his house in minutes. Hint, translate the information into coordinate points. Okay. So x1, y1, x2, y2. Slope equation's this. Okay.
Wait, wouldn't it be no?
So then let's use point slope. Y minus 11 equals negative 1/5 x minus 10. And let's just solve this. Negative x. Negative is positive. Positive 2. This is our equation we're going to go with, right? What is the y-intercept in respect to this problem? What does this mean? Huh? Miles. What about it? He lives 13 miles from school. This is how far school is from his home. Okay? That's the starting point. What is the x-intercept and what does it represent in the context of this problem? Okay, let's see. Let's graph this. Extend that page a little bit. So I'm going to insert a graph, and I'm going to do it as a quadrant somewhere. Oops, out of there. Okay. And I'm going to, let's see, is there a way I can renumber this. So let's not have the numbers up there. Let's do this. Let's go. What did we label X? Minutes. And Y is miles. So minutes, miles. And then let's change our ordering of stuff. Dang magic pen. All right, so I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then, I thought it'd be 0. And then go 0 this way. Okay, so my equation I want to graph is y equals so 13 is about right here. Agreed? And I'm going to go down 1. So I'm going to go down 1 over 5. 2, 4, 5. Do you agree with that if I count it by twos? So down 1 puts me on the line, and then go 2, 4, 5. Guess that's where we would cross.
A long bike ride.
Yeah, it could be.
Wait, Mr. Stroke. So for my slope, I had the same y-intercept and the same equation, except that my slope was -2. So could I just have had x as the...
Did I make a mistake if you had a slope of -2?
Yeah.
Did I make a mistake?
No, you didn't. But
Oh.
I had it as -2 for every 10 miles, or 2 miles for every 10 minutes. So would that work?
Yeah.
Could you just make it into like the cover method by adding 1/5 x?
Oh yeah, we could. All right, so hang on. It says what is the x-intercept and what does it mean? So where's it cross here, and what does that mean?
65.
It means like when you reach a school.
That means when he got to school, right? He's not going to keep riding. Well, unless he was like us when we were little kids riding elementary school. You ride to school and then we had jumps, berms, right? There was always someone who had brought a board so we could set up a ramp to jump off or bikes off. But this is when he gets to school, so he stops riding his bike at that point. So if we were to figure out the x-intercept in the context of this problem, the x-intercept is the point something comma 0. So if I plug 0 in for my y, subtract 13, and multiply each side by -5, so 65. So it takes him 65 minutes to ride to school on the kid's bike. Okay? So once he gets to school, that's where it crosses the x-intercept. He stops riding. The bike is parked and locked up or whatever. However, what is the slope? What does it represent in the context of this problem? Well, this is my slope right here. And the slope was y over x. So y was 11 miles in 10 minutes. So the slope means that he is riding his bike. For every 1 mile he rides his bike, 5 minutes takes place. Make sense? For every 1 mile he rides his bike, for every mile closer Harold gets to his school or his destination, 5 minutes has passed. That's what we have to look at that. How far from school is he riding after 30 minutes? Well, if we're at 30 minutes, which value is the x value and which value is the y value? Is time x or is time y? X. So if I plug 30 in right here, I get -1/5 times 30 plus 13. So 1/5 of 30 is 6, so negative 6 plus 13. So he has ridden 7. How far from school is he? He is still 7 miles from school. How far from home was he? Well, he's ridden 6 miles so far. After how many minutes will he be 6 miles from school? Well, time is here, right? So I'd go 6 equals negative 1/5 x plus 13. Subtract 13, that's what, negative 7? Multiply. 35 minutes takes place for him to get that far. All right, so that's basically your assignment, what it looked like. Understanding the context of the problem is important. It means something. In science, it's going to use during your lab write-ups, your conclusions a lot of times will have a linear equation. So you have to determine what took place with the slope. What was the slope? What did it represent? Okay? And that's how we do these problems. Cool? So we have 20 minutes left. I'm going to do this. I will collect that assignment by the end of the period because I would like you to be able to use it on what we're working on today, which is page 123 to 125.
125.
Page 123 to 125. Okay? Someone flip the